Hi, good morning or good afternoon or good evening. This is Engineer Rolando Garcia Caba, electrical engineer, master electrician, master plumber, and NETA Level 3 as well. I am honored to be part of this modular training center entitled Medium Voltage Switchgear from our very own firm, Stead Saudi Company Limited, focusing in MEP engineering and specialized services. This module based on ANSI, NETA ATS-2009 and BS 7671 and other international and local codes and standards. This training module consists of 4 sessions. Session 1 is quick introduction of MV switchgear, the basic construction, definition, functions, and its application session. 2 is for visual, mechanical, and electrical inspection based on project requirement that complied with MEMA standards and adopted codes and international standards. For Session 3 is for all test report assessment on how to determine that the test results are met in accordance with project specifications and adopted codes and standards. Some test report assessments produced by the test instrument are failed, that require retesting after sometimes or due to some factors affecting humidity and temperatures. And for Session 4 is for quiz, to check the participants are able to understand on this training module entitled Medium Voltage Switchgear.
What is MV switchgear? The medium voltage switchgear refers to a centralized collection of circuit breakers, fuses, and switches, circuit protection devices, that function to protect, control, and isolate electrical equipment. The circuit protection devices are mounted in metal structures. A collection of one or more of these structures is called a switchgear lineup or assembly. Switchgear is commonly found throughout electric utility transmission and distribution systems, as well as in medium to large-sized commercial or industrial facilities. Standards for electrical switchgear are defined by NASI IEEE in North America and by IEC in Europe and other parts of the world. MV switchgear voltage ranges as per ANSI IEEE. From 3 kV to 36 kV, switchgear system is designated as medium voltage switchgear or MV switchgear. This switchgear is of numerous varieties. They may be metal-enclosed indoor-type switchgear, metal-enclosed, outdoor-type switchgear, outdoor-type switchgear without metal enclosure, from enclosure manufacturers.
The MV switchgear construction typically with 2 supply sources and bus coupler circuit breakers CB and O to automatically close when there's any power failure in either source 1 or 2. To ensure there's no power interruptions at normal operations, preventive maintenance schedule, or any purposes. Parts and components of MV switchgear that we must either visually, mechanically, and electrically test and commissioned are as follows. 1. Pressure flaps. 2. Low voltage compartment. 3. Shutter. 4. VCB or SF6 contacts. 5. Relays. 6. VCB or SF6 doors. 7. Vacuum circuit breaker or sulfur hexafluoride. 8. VT compartment. 9. Earth switch. 10. VT bus bar. 11. Rear door. 12. Bus bar. 13. Spout bushing. 14. Current transformer. 15. Power cable compartment. And 16. Truck. Also, metering and its control wirings to verify first the point-to-point check.
What is the standard current rating of medium voltage switchgear? The continuous current rating of switchgear is the amount of current that the main overcurrent protection device and main bus within the switchgear can carry continuously without initiating a trip or damaging the equipment. Continuous current ratings for medium voltage switchgear can typically range from 600 amperes to 4,000 amperes. The medium voltage switchgear is a critical component of electrical power systems, used to control and protect electrical equipment and circuits in the voltage range of 1 kV to 36 kV. It typically consists of circuit breakers, disconnectors, fuses, relays, and other accessories, all housed within a metal enclosure.
Switchgear covers various ranges of equipment that are concerned with interrupting and switching currents under different conditions comprising both normal and abnormal. It includes fuses, switches, relays, circuit breakers, and various other equipment. Switch. A switch is used for opening and closing the electrical circuit conveniently. It may be used in different conditions that may be full load or no load. However, it cannot interrupt the faulty currents. Every time the contactive switch is opened, an arc is being produced in the air present in between the contacts. This is true in the case of circuits having high voltage and capacity for large currents. The switches may be classified into oil switches, air brake switches, and disconnecting or isolator switches depending upon the opening of their contacts. Fuse. A fuse is a thin strip or a short piece of wire which melts down when excess current flows through it for a sufficient time period. It is being inserted in series with the circuit which is to be protected. In the case of normal operating conditions, the fuse is known to the element it at a temperature that is below the point of melting. It is known for carrying the normal load current without any overheating taking place. In cases when an overload occurs or a short circuit happens, the current passing through the fuse increases the element beyond the capacity that is rated. This is known for raising the temperature that leads to the melting of fusing elements, further disconnecting the circuit that is being protected by it. This is how the equipment and machines are being protected from any type of damage that is caused due to the excessive currents. A fuse is known for performing various interruption and detection functions. Circuit breakers. A circuit breaker is switchgear equipment that is used to open and close the circuit under various conditions comprising of full load, no load, and other faulty conditions. It is designed in such a way that it can be operated manually or by using remote under normal as well as faulty conditions. The relay circuit is being used with a circuit breaker for the latter operation. The circuit breaker consists of fixed and moving contacts that are enclosed in a robust metal tank and further immersed in oil known as transformer oil. Relays. A relay is a device that is used for detecting the fault and supplying the information to the breaker for the interruption of the circuit. The main winding of the current transformer is being connected in series along with the circuit that is required to be protected. The initial winding comprises the main conductor. The second circuit comprises the secondary winding of the current transformer that is connected to the relay operating coil. The third is the tripping circuit that consists of a supply source, relay stationary contacts, and a trip coil of the circuit breaker.
For the Session 2 is for visual, mechanical, and electrical test inspection for MV switchgear. Thank for watching.
Testing and commissioning for medium voltage switchgear. Previous Session 1 is quick introduction of MV switchgear. Now is for Session 2 visual, mechanical, and electrical testing and commissioning inspection based on project specifications and adopted codes and standards. Prior to conduct visual, mechanical, and electrical test inspection, MV switchgear must be isolated from incoming and outgoing terminations, barricaded and free from any unnecessary adjacent materials prior to starts testing. Locked-out, tag-out, or load-out procedure must be followed and adheres all permits required, and safety protocols and PPE must be worn as shown example picture. Also, T&C activity must secured all necessary documents, scheme drawings, permits, start card also available in workplace and signed off by all personnel within the team after the pre-job meeting. Optional test. The purpose of these specifications is to assure that all tested electrical equipment and systems supplied by either contractor or owner are operational and within applicable standards and manufacturers' published tolerances, and that equipment and systems are installed in accordance with design specifications. Certain tests are assigned an optional classification. The following considerations are used in determining the use of the optional classification. 1. Does another listed test provide similar information? 2. How does the cost of the test compare to the cost of other tests providing similar information? 3. How commonplace is the test procedure? Is it new technology? Manufacturer's instruction manuals. It is important to follow the recommendations contained in the manufacturer's published data. Many of the details of a complete and effective testing procedure can be obtained from this source. Summary. The guidance of an experienced testing professional should be sought when making decisions concerning the extent of testing. It is necessary to make an informed judgment for each particular system regarding how extensive a procedure is justified. The approach taken in these specifications is to present a comprehensive series of tests applicable to most industrial and larger commercial systems. In smaller systems, some of the tests can be deleted. In other cases, a number of the tests indicated as optional should be performed. Likewise, guidance of an experienced testing professional should also be sought when making decisions concerning the results of test data and their significance to the overall analysis of the device or system under test. Careful consideration of all aspects of test data, including manufacturers' published data and recommendations, must be included in the overall assessment of the device or system under test. The following test equipment or test device that are required to execute the works. 1. Insulation resistance tester. 2. CPC 100. 3. Secondary injection test kit. 4. Clamp, multimeter AC/DC. 5. High voltage tester 120 kV, dielectric test set. 6. Circuit breaker timing test kit. Example here is TM1700. 7. CT analyzer. 8. DLRO 200 ampere. 9. Torque wrench. Local wiring, point-to-point check. The following items will be checked. Visual check of transport damage, completeness and correct positioning. Cubical wiring checked according to circuit diagram. Integrity of grounding connections checked. AC auxiliary power supply, heating and lighting checked. DC auxiliary power supply, polarity. Test sockets, plugs and shorting hardware checked. CT circuits checked. Input signals logic and circuits checked. Tripping and auxiliary relays, logic and circuits checked. Interlocking logic and circuits checked. Signaling circuits and alarms checked, and MV switchgear must be earthed. And all must be visually and mechanically checked prior to start electrical testing. All results will be recorded on test record sheet. For meters calibration. For voltmeter calibration, connect the secondary injection test set to the voltmeter terminals. Inject and increase the voltage gradually. 1. From 0 to 25%, 50%, 75% and 100% of the full-scale voltage of the voltmeter. 2. Record the corresponding voltmeter readings. 3. Inject 100% of the normal voltage record the corresponding voltmeter reading on the test record sheet. For ammeter calibration, connect the secondary injection test set to the ammeter terminals. Inject and increase the current gradually. 1. From 0 to 25%, 50%, 75% and 100% of the full-scale current of the ammeter. 2. Record the corresponding ammeter readings. 3. Inject 100% of the normal current record the corresponding ammeter reading on the test record sheet. SF6 testing, Figure 2. The test object, pressure gauge, will be connected to the test set as shown in the arrangement drawing. During the test, firstly, the pressure will be increased by means of the manual operated pump up to a level above of the setting values of the gas monitoring warning contacts. After this, the pressure will be lowered by means of the fine adjustment facility at the test set so that the pressure value runs through the setting values. Thereby, the correct pressure indication at the test object and the switching of the warning contacts at the correct level are to be observed. All results will be recorded on test record sheet. CT testing, as shown arrangement drawing. Insulation resistance test of the CT. Measurement of the insulation values. A. Between each secondary core and earth. B. Between the secondary cores. Current transformers and voltage transformers are referred to as instrument transformers. They are used in electrical power systems for stepping down currents and voltages of the system for metering and protection purposes. Actually, relays and meters used for protection and metering are not designed for high currents and voltages of electrical power systems. These cannot be fed directly to relays and meters. CTs step down the rated system current to 1 amp or 5 amps. Testing the CT parameters ensure correct measurements are taken off these instruments, and that the protection devices connected to them are operating in according to their correct, safe design values. All results will be recorded on test record sheet. The ratio test required for CTs and VTs. For CT ratio test and burden as shown arrangement drawing in Figure 5. This test is to verify the CT's turns ratio and accuracy at all taps. To test a CT ratio, basic transformer theory applies. One of the simplest transformer fundamentals is that the transformer turns ratio varies directly with current. A 400 to 1 CT ratio will convert 400 primary amperes to 1 secondary ampere. The circuit connection shall be made such that 400 amperes of the rated primary current shall be injected on the CT primary side with the secondary side shorted. The secondary current can then be measured and recorded for all taps. For CT polarity test as shown arrangement drawing in Figure 6. The polarity of current transformers is extremely important. It determines the direction of the secondary current in relation to the primary current. Wrong connection of the current transformers can cause false operation of the protection relays. Hence, it is vital to ensure that the current transformers are connected with the correct polarity. To test the polarity of a current transformer, a DC source is connected with the positive terminal to P1 and the negative terminal to P2, as shown in the figure. All results will be recorded on test record sheet. For CT winding resistance test as shown in arrangement drawing in Figure 7, the purpose of measurement is to check correctness of windings and terminal connections. Winding resistance of CT will measure using digital millimeter. Temperature correction will be made according to reference temperature 75 degrees Celsius. Ambient temperature must be measured and resistance values to be calculated for reference temperature. Connect the multimeter across the R-phase CT secondary S1, S2. Measure and record the resistance value in the test form. Repeat the same steps for the other phases, Y and B phases, and record the values. For CT magnetizing curve, knee point as shown in figure number 8. Connect the test probes from CPC 100 to the terminal 1s 1 and 1s 2 of the CT. On CPC 100 for knee point or CT excitation test card to record the excitation curve of the current transformer. This test performs an automatic injection of test voltage of up to 2 kV to the CT's secondary side and test results are automatically generated. For VT testing, insulation resistance test as shown in arrangement drawing. Measurement of the insulation values. 1. Between each secondary winding and earth. 2. Between the secondary windings. 3. Between primary and secondary windings. 4. Between primary and earth. For VT ratio test as shown in Figure 10, this test is to verify the VT's turns ratio and accuracy at all taps. To test a VT ratio, basic transformer theory applies. One of the fundamentals is that the transformer turns ratio varies indirectly with voltage. At 22 kV, square root 3.11 kV, square root 3 VT ratio or 110 volts on secondary of VT. The steps for a ratio verification test are as follows. 1. Connect a voltage source, CPC 100, HV test probes across the VT primary R phase and endpoint. 2. Connect CPC 100 voltage input to across the VT secondary. 3. Set the CPC 100 test card into VT ratio, then manual test. 4. Calculate the ratio between the two voltages. 5. This voltage should match the VT ratio. Primary, secondary. All results will be recorded on test record sheet. For VT polarity test as shown in Figure 11, the polarity of voltage transformers is equally as important. The same principles and testing techniques as the CT polarity apply here as well. In CPC 100, connect the test probes to the VT terminals, then set the test card and manually test. The test results will be automatically generated. And for VT winding resistance test, the purpose of measurement is to check correctness of windings and terminal connections. Winding resistance of VT will measure using digital millimeter. Temperature correction will be made according to reference temperature, 75 degrees Celsius. Ambient temperature must be measured and resistance values to be calculated for reference temperature. All results will be recorded on test record sheet. Insulation resistance before and after high-pot test for bus bars of MV switchgear, but prior on the all-bolted electrical connection must done contact resistance test to values of similar connections. Investigate values which deviate from those of similar bolted connections by more than 50% of the lowest value section 7.5.3.1.11.1 and for bolt torque levels shall be in accordance with manufacturer's published data. In the absence of manufacturer's published data, use Table 100.12, Section 7.5.3.1.11.2. Contact resistance measurements. Close the circuit breaker, the micro-ohmmeter or DLRO test kit and set with a current of 100 amps DC. Connect the test probes to the R phase of the circuit breaker. Record the reading. Repeat it for all CB phases. For circuit breaker tests, visual inspection. Check nameplate information for correctness. Check tightness of all bolted connections, torque wrench method. Check all wiring is correct according to approved drawings. Terminal connections are secured. Check quality of paintwork. Check that all grounding cables are securely connected. Check breakers, truck, rails, for proper alignment and smooth movement. Check operation of all mechanical interlocks with associated disconnects, grounding switches, racking truck mechanism, cubicle doors, etc. Check for correct breaker position indication, breaker open, closed. Check manual spring charge operation. Verify correct spring status indication, spring charge discharged. Verify that correct dispatch numbers have been installed. Contact resistance measurements. Close the CB as shown in Figure 13. The VCB or SF6 must be drawn out and test away from switchgear panel, then or the breaker elements can be removed from the switchgear cubicles on wheel rollers for this testing. the micro-ohmmeter or DLRO test kit and set with a current of 100 amps DC. Connect the test set probes to the R phase of the circuit breaker. Record the reading. Repeat it for all CB phases. For insulation resistance test for circuit breaker insulation resistance test at 5 kV DC as shown in Figure 14. Perform insulation resistance tests for 1 minute on each pole, phase to phase and phase to ground with switch closed, and across each open pole as such follows. At the CB open, connect the phases R, Y, B cable side to the ground. Connect the phases R, Y, B bus side to the high potential test set. Record the corresponding insulation resistance readings. At the CB closed, connect the phases Y, B to ground and apply the test voltage between phase R and ground. Connect the phases B, R to ground and apply the test voltage between phase Y and ground. Connect the phases R, Y to ground and apply the test voltage between phase B and ground. Apply voltage in accordance with manufacturer's published data. In the absence of manufacturer's published data, use Table 100.1. Record the corresponding insulation resistance readings. For high potential test for circuit breaker, AC high pot test shall be carried out in accordance with NETA Table 100.6, however, or vendor recommended to applies, and the test will carry out at test voltage 40 kV for 60 seconds. By best practice on site, the test had been done at factory. It will be done at site at 80%. This also carried out bus of MV switchgear on this setup, however it is also acceptable to conduct CB draw out or isolated and away from MV switchgear panel. Considering as per IEC 60950, the basic test voltage for high pot test is the 2 times the operating voltage plus 1000 volts for 1 minute at typical high pot equipment. Leakage current trip limit settings range between 0.1 and 20 milliamperes. The reason for using 1000 volts as part of the basic formula is that the insulation in any product can be subjected to normal day-to-day transient overvoltages. For breaker timing test, by the use of TM170 kit means fast and easy testing. Testing is done with a 3-step process. First step, select a suitable template from the template library, depending on number of contacts per phase, motion or not, resistor contacts, and more. Second step, connect the test leads according to the graphical help screen, separate help screens for each cable. Third step, turn the measure knob. The measurement is performed, analyzed, and the results displayed on the screen. Magnification and compare functions are available. Simultaneous measurements within a single phase are important in situations where a number of contacts are connected in series. The breaker becomes a voltage divider when it opens a circuit. If the time differences are too great, the voltage becomes too high across one contact, and the tolerance for most types of breakers is less than 2 milliseconds. The time tolerance for simultaneous measurements between phases is greater for a 3-phase power transmission system running at 50 Hz, since there is always 3.33 milliseconds between 0 crossovers. Even so, the time tolerance is usually specified as less than 2 milliseconds for such systems. It should also be noted that breakers that perform synchronized braking must meet more stringent requirements. There are no generalized time limits for the time relationships between main and auxiliary contacts, but it is important to understand and check their operation. The purpose of an auxiliary contact is to close and open a circuit. Such a circuit might enable a closing coil when a breaker is about to perform a closing operation and then open the circuit immediately after the operation starts, thereby preventing coil burnout. Next topic is for Session 3 assessment for all test reports for optional test for medium voltage switchgear. Thank you. Then prepare for a quiz.